Welcome back to Simplified Chemistry. In this video, I am going to show you how to calculate percentage yield using the number of moles. Here I'm showing you an example where aluminium oxide is decomposing to give aluminium. We are asked to calculate the percentage yield when 20 grams of aluminium was produced from 50 grams of aluminium oxide. In the real world, when we perform experiments, most experiments do not go to 100% completion. Sometimes you get side reactions and sometimes you might lose some of your product, for example, when you do filtration. So we never get 100% yield from a chemical reaction in a lab. To calculate the percentage yield, we have to divide the actual yield by the maximum theoretical yield and multiply that by 100. The actual yield is the amount of substance that you actually obtain from the experiment you have performed. The maximum theoretical yield is the amount of substance that you would expect to get if the reaction was perfect. Here we have been given the actual yield. 20 grams of aluminium was produced. We need to convert the mass into number of moles. The number of moles of aluminium that was produced is equal to the mass of aluminium divided by the molar mass of aluminium. If you're given the mass in any other unit, you must convert the mass into grams first. The actual yield of aluminium in moles is therefore equal to 20 grams divided by the molar mass of aluminium, and this gives us 0.741 moles. Now we need to work out the maximum theoretical yield of aluminium. The maximum theoretical yield of aluminium will depend on the amount of the aluminium oxide. 50 grams of aluminium oxide was used in this chemical reaction. The number of moles of aluminium oxide is equal to the mass of aluminium oxide divided by the molar mass of aluminium oxide. This is equal to 50 grams divided by 101.96, and this gives us 0.490 moles. Remember, the maximum theoretical yield of aluminium depends on the amount of the aluminium oxide. Based on these ratios, the amount of aluminium is twice the amount of the aluminium oxide. Therefore, if the reaction was perfect, the maximum theoretical yield is equivalent to 0.981 moles. Now that we have both values, the actual yield, which is equal to 0.741 moles, and the theoretical yield, which is 0.981 moles, we can calculate the percentage yield, which is equal to 0.741 moles divided by 0.981 moles. Multiply the value by 100, and this gives us 76% yield. In this video, I have shown you how to calculate percentage yield using number of moles. In part 2, I will show you how to calculate the percentage yield from masses.